What if the world around you is constantly writing a message? A message that's being carried on every single ray of light. Today, we're going to dive into a scientific paper that proposes exactly that. A really mind-bending theory that our environment is communicating with us in a way we have never, ever imagined. And I don't mean that in some metaphorical, new agey sense. I mean, what if the air itself, the actual space between you and the screen, is encoding a physical signal, a hidden layer of information carried on the light that is hitting your eyes right now? Well, that's the core idea of a brand new paper by Ido Margolin. It suggests that all those tiny particles floating around in the atmosphere, dust, pollen, aerosols, they aren't just passive junk. Nope. They are actively writing a complex signal into the light that's passing through them. And here's the kicker. It's not a message in space, but a message in time. Okay, but how could the air itself write anything? That sounds a little nuts, right? Well, to understand that, we need to look at the first big piece of this theory, the air as a writer. The paper gives it a name, a temporal interference field. So let's break that down. It's an invisible pattern, right? And it's written into light by all those particles in the air. But here's the part you really got to grab onto. This isn't a pattern in space, like a shadow on the wall. It's a pattern in time. A better way to think about it is like a rhythm or a musical beat, a series of peaks and valleys of information that unfold over just a few milliseconds. So how exactly does the air write this message? Well, the paper lays out a pretty clear process. First, you start with a clean, simple pulse of light coming from the sky. Step 2, that light has to travel through our atmosphere, which is basically this complex soup of dust and spores and pollen. Finally, when the light comes out the other side, it's not the same. It's been changed. It's now carrying what the paper calls a new temporal signature. This whole process is the environmental kernel, or as I like to think of it, the writer. And here's the really cool part. This isn't just a vague idea. It's something we can actually measure. Scientists can analyze that altered light for specific changes, which the paper calls temporal interference indices, or TII. So they can measure if the light pulse got stretched out over time. That's called broadening. They can see if the signal has a longer, more persistent memory, or a heavy tail. They can even detect shifts in its color and its polarization. That is, the very orientation of the light waves. These are basically the individual letters that make up the message being written by the air. So, if the air is writing a message, that leads to a pretty obvious next question, right? Is anyone, or anything, reading it? And that brings us to the second, equally wild part of this theory, biological readers. And the theory says, absolutely, yes, something is reading it. It suggests that biological organisms, and yeah, that includes us humans, have systems built in that can unconsciously receive and interpret these temporal signals. This is the whole second half of the model, the reader kernel. And the paper gets super specific about it, proposing 2 possible reader mechanisms. For animals, like birds or insects, it could be tied to their magnetic sense, which uses a special light-sensitive protein to navigate. But for us humans, it might be linked to our own attention system, a really deep part of the brainstem that controls our focus and arousal. And the most fascinating part is that we could potentially measure this by tracking tiny, unconscious changes in our pupil size and how often we blink. Now, I know what you might be thinking. This sounds a little out there, right? Like pure science fiction. But what makes this a compelling scientific paper is that it's all built around a practical, real-world way to either prove it or disprove it. So let's look at Section 3, how to actually test the hypothesis. So what's the biggest challenge for a scientist here? How in the world could you prove that it's the dust in the air that's affecting someone's perception and not just some random flicker in their own brain? How do you separate the writer from the reader? Well, the paper proposes this really clever 3-step experiment to isolate the signal. First, C0, you measure a person's perception of time in perfectly clean air. That's your baseline. Next, C1, you introduce temporal noise into the light, but, and this is key, without the color or polarization changes that dust would cause. This lets you test the reader system all by itself. And finally, C2, you introduce a controlled cloud of actual dust. So here's the punchline. If a person's sense of time changes in step 3, but it didn't in step 2, that's really strong evidence that the medium, the dust itself, is the cause. And what's crucial to understand is that this hypothesis doesn't just come out of nowhere. It's built on a ladder of established scientific facts. We already know that air pollution broadens light signals. That's a fact. We know that polarized light affects bird navigation. Fact.
We know our pupil size is linked to our attention. Another fact. This new idea that dust patterns can affect our perception of time is the next, logical, even if it's a massive, step up that ladder.
Okay, so let's just imagine for a second that this theory is proven to be correct. What would that actually mean for us? Well, that brings us to some pretty stunning future applications, like the idea of forecasting temporal weather.
This is probably the paper's most ambitious idea. Temporal weather would be a totally new kind of forecast. It wouldn't predict rain or sun. It would predict how the stuff in the air, the dust, the pollen, is going to affect light signals, and maybe, just maybe, our own perception and attention over a specific area.
And this isn't just some academic daydream. I mean, think about the real-world applications. You could alert airline pilots or even drivers to atmospheric conditions that might subtly distort their perception of time. You could map how a city's air quality might be impacting public health and cognitive function on a massive scale. It's a direct line from the physics of tiny particles to huge, real-world safety issues.
There's a line in the paper that just perfectly captures this whole paradigm shift. It says, the claim isn't that information is lost, but that it's redistributed into temporal correlations and environmental archives. In other words, the information isn't destroyed by the dust. It's just translated into a new language, the language of time.
Which, leaves us with one last, truly fascinating thought. If this theory holds up, will we one day find ourselves checking a forecast not just for rain or sun, but for time itself? Will you pull out your phone to see what the temporal weather is for the day? It's a pretty profound question about the hidden layers of information that might be all around us, all the time.